This is my intermediate algebra course. Today we're going to learn absolute value equations and inequalities. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. So first we're going to talk about absolute value. These are absolute value symbols. And if you take the absolute value of a positive number, the number just stays the same. It doesn't change. If you take the absolute value of a negative number, it changes the negative to a positive. It's that simple. So again, if it's a positive number, it stays positive. If it's negative, it changes to positive. That's the most important concept for today. And again, this is just notation. So why don't you do example number 3, what is the absolute value of 36? If you said 36, you're correct. And what is the absolute value of negative 1,047? If you said positive 1,047, you're correct. Again, a positive just stays positive and a negative changes to a positive. So now we're going to do absolute value equations. And what this equation is asking is, what are the possible values of x that will make this equation work? So isn't it true that if we plug in 8, the absolute value of 8 is 8, so it works? Isn't it also true that if we plug in negative 8, the absolute value of negative 8 is 8, so that works too? Because again, remember, a negative inside the absolute value, that just changes to positive. So there are two solutions to this equation. X equals 8. It equals the positive of this number, and it also equals the negative of that number. So we can say that x equals 8 or x equals negative 8, and that is the solution. All right, so number 2 is pretty much the exact same thing. So why don't you try number 2, and when you come back, we'll do it together. All right, we're back. So y can be 3, but y can also be negative 3. And that is the solution. So if you got that answer, good job. So now we're going to go to some more complicated problems. And these problems, notice that the absolute value is not isolated. It's not by itself because a 3 is next to it. In these problems, the absolute value started off isolated, so we didn't really have to do much algebra. But in this problem, we do have to isolate the absolute value expression, so we're going to have to get rid of that 3. So we're going to subtract 3 from both sides. Whoops. And we get 4. Absolute value of b is equal to 4. And so now that we isolate the absolute value, now we can just break it up into two parts. So b is equal to negative 4. Actually, positive 4 I'll do first. Or b can also be equal to negative 4. And that is the answer. And if you want to check that to make sure, plug in 4. The absolute value of 4 is just 4, because a positive stays positive. Add it to 3 and you get 7. So this answer worked. Now let's plug in negative 4. Absolute value of negative 4 is 4, because a negative changes to positive, and then 4 plus 3 is 7. So we see it worked. So that's one way to see if you did it correctly, is to plug the answers back in. All right, so why don't you try number 4? Again, you have to get this absolute value expression by itself. So you're going to have to get rid of that negative 2. Try number 4. When you come back, we'll do it together. All right, we're back. I'm going to add 2 to both sides. And now we've isolated the absolute value, so we're ready to break it into parts. And x can be equal to 12, or x can be equal to negative 12. And it doesn't really matter which way you put those equations, you can flip them. So if you got those answers, good job. Okay, on to number 5. We're just doing the same type of thing, but now we have a fraction. We have to isolate the absolute value. Again, you always isolate the absolute value first. So we're going to multiply both sides by 4, because this is absolute value of y divided by 4. So we have to do the opposite of multiplication, or opposite of division, which is multiplication. So multiplying both sides by 4. And now the absolute value is isolated. So we're ready to break it into parts. So y can be equal to 8, or y is equal to -8. So why don't you try number 6, and when you come back, we'll do it together. All right, we're back. So we're going to multiply both sides by -5, and we get 10. And b is equal to +10, or b is equal to -10. So if you got those answers, good job. And again, you can plug in, so absolute value of 10 is 10 divided by -5 is -2, that worked. Absolute value of -10 is 10, 10 divided by -5 is -2, that worked also. All right, so now we have a problem where there's multiplication involved. Now this is a source of confusion for students. See how this 2 is right next to the absolute value symbol? That means multiplication. So we need to get rid of that 2, so we have to do the opposite of multiplication. And so we're going to divide. So we have 9 over 2 is equal to absolute value of x. And now we've isolated the absolute value expression. So we can break it up into parts. So 9/2 is equal to +x, or -9/2 is equal to x. And those are the solutions. So why don't you try number 8? Again, we want to isolate the absolute value, and then after you isolate it, you can break it into parts, as we did here. So try number 8, and when you come back, we'll do it together. All right, we're back. So we're going to divide both sides by 5, and we get absolute value of y is equal to 2. Break it into parts, and we have y is equal to +2, or y is equal to -2. So if you got those answers, good job. All right, so now we're getting a little more complicated. Again, we need to isolate the absolute value before we can break it into parts and find the solutions. But we have a 3 and a -7. So it's not isolated. We have to get rid of the -7 and the 3. So what we're going to do is add 7 to both sides. And I'm going to go ahead and just show the steps on this problem. I want to be clear. You don't have to show these steps because this is just basic algebra, but it may have been a while since you did this kind of algebra. We did do some of this in my geometry course, but if you've taken a break from the geometry after finishing that course, then you may need a little refresher on this stuff. So we're adding 7 to both sides, and we get 11 on this side. And the -7 cancels out with the +7. And now, again, just for your sake, I'm going to rewrite. Divide both sides by 3. Again, students need to understand that when a number is right next to that absolute value, it's multiplication. So then we get absolute value x equals 11 over 3, and now we've isolated the absolute value. So that means we're ready to break it into parts. So x is equal to +11 over 3, or x is equal to -11 over 3. And there you go. So let's do one more of those. And again, I showed every step on that one, but you don't have to show the steps. And I'm gonna show on this problem what exactly I expect you to show as far as work. So we're going to isolate the absolute value. We're going to subtract 3 from both sides and multiply both sides by 2, and we get 24 is equal to the absolute value of y. And then we isolated the absolute value, so now we're ready to break it into parts. So 24 is equal to y, or -24 is equal to y. So that, again, that means that 24 is a solution, but -24 is also a solution. All right, so this is all I really require that you show. You don't have to do all this stuff. I'm only doing this as a refresher. So let's go on to number 11 here. Now it's time for you to try. So attempt number 11. Remember, the whole purpose here is isolate that absolute value, and then once you isolate it, you can separate the equations. Try number 11, and when you come back, we'll do it together. All right, we're back. We're going to get 1 is equal to the absolute value of b. It's probably best if you make your absolute values fairly tall there. And then we can separate because at that point the absolute value is isolated. So b is 1 or -1. So if you got those answers, good job. So now absolute value of x is equal to 27. Separate and we get x is equal to 27 or x is equal to -27. So if you got those answers, good job. All right, so for the next problems, we'll do these next two together. These are just some problems where the algebra may be a little cumbersome for you, or there may be a few mistakes made. It's important to understand that this negative goes with this expression. It has nothing to do with the 1. So let's see if I can show the steps on this one. What you can do is you can change this to a positive and then put the negative in the denominator. That might be a lot easier for you to see what's going on. And now we're going to subtract 1 from both sides, and we get -7 is equal to absolute value of b over -3. Then we're going to multiply both sides by -3, and we get 21 is equal to the absolute value of b. And then we're ready to separate because at that point b is isolated, so 21 is equal to b or -21 is equal to b. And those are your solutions. So again, the big issue with that is this negative here. You have to consider that as a part of this, and you can get rid of it by just multiplying both sides by -3. You can get rid of the 3 and the negative at the same time. There's multiple ways to show that, multiple ways to do that, but as long as you get the right answer, whatever method you use is fine. So now we're going to subtract 2 from both sides, and we get -2 is equal to negative absolute value of x. And we're going to divide both sides by -1. And you know what? I think I might show the steps on this if I have room. Again, I just don't want you to make these errors here. So now we're going to subtract 2 from both sides. And we get -2 is equal to negative absolute value of x. Now it's important to understand that this expression is just considered to be -1 times absolute value of x. So we want to get rid of that -1. Again, we have to get the absolute value of x by itself. A lot of students would stop here and say, we found it. You didn't find it because you haven't isolated the absolute value yet. So we're going to divide both sides by -1. And now we have 2 is equal to absolute value of x. And we can separate, and x equals +2 or x equals -2. Let me move this down a little bit. Go into attempt number 15. Remember, this negative goes with this. So when you take away the 7, the negative is not going anywhere. So be very aware of that. So try number 15, and when you come back, we'll do it together. All right, we're back. So you're going to subtract 7 from both sides, and we get -3. And that negative is still hanging out on that absolute value. So we have to, that's the same thing as -1 times the absolute value of b. Divide both sides by -1, and we get the absolute value of b is equal to 3. And then b is equal to 3, or b is equal to -3. So if you got those solutions, good job. All right, try number 16. And remember, the -2 goes with the y. When you take away the 4, it's not gonna do anything to the -2. So try 16, and when you come back, we'll do it together. All right, we're back. So we're going to subtract 4 from both sides. And we get -2 is equal to negative absolute value of x. So we're going to divide both sides by -1. And we get -2 is equal to negative absolute value of b is equal to 3. And then b is equal to 3, or b is equal to -3. So if you got those solutions, good job. All right, try number 17. And remember, the -2 goes with the y. When you take away the 4, it's not gonna do anything to the -2. So try 16, and when you come back, we'll do it together. All right, we're back. So we're going to subtract 4 from both sides. And then we're going to divide both sides by -2, and we get 1/2. So we isolated the absolute value, so now we're ready to break it up into two equations. So y is equal to 1/2, or y is equal to -1/2. So if you got those answers, good job. All right. So now we're going to go to some specialty problems. I just want you to be aware that sometimes weird things happen with these equations. So you're going to see on this problem, we're going to isolate the absolute value as usual. We'll subtract 2 from both sides, but now we come up with a weird situation. There's actually no solution to this equation. Can you see why? Well, remember, when you plug in, let's plug in positive 5 to the equation and see if it works. And what you'll see is it does not work, because the absolute value of 5 is 5, and that's not equal to -5. So if we plug in positive 5, we don't get an answer. Now let's try plugging in -5. Maybe that'll give us the answer, or maybe that'll be a solution. But the absolute value of 5 is positive 5, so again, we can't get -5. In fact, it's impossible to plug in some y value that will give you -5, because the absolute value of a number is always positive. So for this, we just say, and I'm going to write it in red, no solution. So you may see some of those in the homework for absolute value equations. So when an absolute value is equal to a negative, and the absolute value is isolated, that means there's no solution. So try number 18. That's going to be a similar situation, and I want you to explain to me why 18, after you isolate the absolute value, you can see why there's no solution. So try number 18, and when you come back, we'll do it together. All right, we're back. We're going to multiply both sides by -3, and we get -12 is equal to the absolute value of b. So explain to me why that's impossible. And the explanation obviously is, well, an absolute value can't be a negative. So no solution. So I know that's kind of tricky to throw those at you, but you might see those. There's a possibility you might see these types of problems where it's just impossible to plug in a value there that will give you -12. And again, all you have to remember is an absolute value, when it's isolated, it cannot be equal to a negative. So if you got that answer, good job. So now we're going on to a little more complicated problems. So look what's inside the absolute value. In all the previous problems, we only had a single expression, a single variable. We didn't have any kind of operations inside the absolute values. But now we have an actual operation. We have a sum of two numbers. So it's just getting a little bit more complicated. The good news is the absolute value is already isolated, so we can immediately break it into parts. And it works the same way. What's inside the absolute value can be +7, or what's in the absolute value can also be -7. So it's very easy. It's the same situation. So now we just solve both equations. Subtract 2 from both sides, and we get 5. Subtract 2 from both sides, and we get -9. And that is the solution. So very easy. Same situation, same thing that we were doing before. So let's try another one of these. The absolute value is already isolated, so we can just go ahead and break it into parts. So we know that 3y can be equal to +4, or 3y can be equal to -4. That's just the way it works. We're not doing anything different here. It's the same scenario. So now we just solve, and we get y is equal to 4/3, and y is equal to -4/3. And those are the solutions. So why don't you try number 21? And again, we don't have to isolate the absolute value. It's already isolated, so you can just go ahead and break these into two equations. Try 21, and when you come back, we'll do it together. All right, we're back. So the absolute value is already isolated, so 2 is equal to -3 plus b, but negative 2 can also be equal to negative 3 plus b. So add 3 to both sides and we get b is equal to 5. And add 3 to both sides and we get b is equal to 1. So if you got those answers, good job. Go ahead and try number 22, and when you come back, we'll do it together. All right, we're back. So the absolute value is already isolated, so we can just go ahead and break it up into parts. So x over negative 3 is equal to positive 10, but it can also be equal to negative 10. Let me move this over a little bit. So same situation here. So we're going to multiply both sides by negative 3, and we get x is equal to negative 30, or x is equal to, whoops, keep trying to write a fraction there. X is equal to positive 30. And those are the solutions. So if you got those answers, good job. All right, on to number 23. And now number 23, we're pulling out all the stops now. Now we're getting really complicated with this equation, but it's the same procedure. All you're going to do is just isolate the absolute value, get that by itself. It's not by itself because the 4 and the 3 are next to it. So we're going to subtract 4 from both sides, and we get 6. And at this point, we're going to divide both sides by 3, because again, when a number is next to an absolute value, that means it's multiplied into the absolute value. 3 is multiplied into this absolute value. Students have a lot of trouble with that. Not exactly sure why, but all right. So after all that, we have we've isolated the absolute value. But again, you don't have to show all that. That's just beginning algebra stuff. When you get into upper math, you don't have to show every step because it would just get too tedious. So now we know that 5x minus 2 can be equal to 2, or 5x minus 2 can be equal to negative 2. And you want to try to keep your equal sign straight down from the equation. But if it's not possible to do that because you don't have enough room or whatever, that's okay. So now we just solve. Add 2 to both sides, divide by 5, so we have x is equal to 4/5, or x is equal to 0. So again, we're just getting more and more complicated as we go here. And again, you can check your answers to be absolutely sure. All right, number 24, let's do another one of these before you try one on your own. We're going to do a bunch of these before you try one on your own. So add 2 to both sides, divide by 6, and we get 4. Now, again, in this problem, I showed every step, but in this problem, I'm going to show what I require from you. I don't require you to show every single step. So again, add 2 to both sides, you get 24 over here, then divide both sides by 6, and you get 4. So we've isolated the absolute value, and you could do that in your head. So now we know that positive 4 is equal to y over 5 plus 3, or negative 4 is equal to y over 5 plus 3. So now we just solve, and we get y is equal to 5. And I have plenty of room down here, so I guess I can go down one more line. Or y is equal to negative 35. And again, if you doubt that your answer is correct, you can just plug it in. So plug in 5. 5 divided by 5 is 1, plus 3 is 4. Absolute value of 4 is 4. 4 times 6 is 24. 24 minus 2 is 22. Now plug in negative 35. Negative 35, whoops. Negative 35 divided by 5 is negative 7. Negative 7 plus 3 is negative 4. Absolute value of negative 4 is 4. 4 times 6 is 24. 24 minus 2 is 22. I'm sorry if I'm going fast, but I'm just demonstrating the point that you can plug it back in and make sure that your answers are correct. So let's try a couple more of these before you try one on your own. This is kind of a specialty problem here. In fact, I should probably put like should probably get a different color here and put like maybe a star next to that. So we're going to isolate the absolute value as usual. We have to get rid of the -5 and the 2. So we're going to add 5 to both sides, and we get 0, and then multiply both sides by 2. Or maybe I should do that. Sorry, I'm trying to conserve room here, but whenever I predict that students are going to have trouble with something, I'll try to show the steps for it. And so we're going to add 5 to both sides. And by the way, if you're having trouble with a lot of this algebra, that probably means that you didn't take my algebra course. So -5 plus 5 is 0. And the 5's on the other side cancel out, so we have absolute value of b over 3 minus 4 over 2. As you go into upper mathematics, if you have gaps in your knowledge of the algebra, it's going to start to become more and more apparent. But the good news is you're going to start to master algebra as you go up into the advanced levels. But it is going to require effort. Okay, so now I'm going to rewrite that. Again, you don't have to rewrite all this stuff. I'm just doing this for your benefit. So now we're going to multiply both sides by 2. And 2 times 0 is just 0. So we have 0 is equal to absolute value of b over 3 minus 4. And now this is a weird situation. We haven't encountered this situation before because the absolute value is now equal to 0. I mean, you could break it into 2 parts, and b over 3 minus 4 is equal to positive 0, or b over 3 minus 4 is equal to negative 0. But negative 0 is the same thing as 0. So you really don't have to break it into 2 parts. The only thing that this inside part could possibly be is 0. There's nothing else that it could be. So b over 3 minus 4 is equal to 0. And then solve that equation, and we get b is equal to 12. I'm going to shrink this a little bit. So b is equal to 12. That's the only solution that works. Okay, so let's try another one of these. We're going to isolate the absolute value, and we get 3. And now that the absolute value is isolated, we know that 3 plus 2x can be positive 3, but we know 3 plus 2x can also be negative 3. So now we just solve and we get x equals 0 over here, or x equals negative 3. Again, we're just practicing algebra here and practicing absolute value equations. On to 27. So now it's time for you to try, and I'm going to leave these in the window if you need help with those. So try number 27, and remember, it's the same procedure. You want to isolate that absolute value and then break it up into 2 equations. And you know what? I'm going to start with a different one there. So let me switch this around for you. That was not the best one to start with. So try number 27, and when you come back, we'll do it together. All right, we're back. So add 3 to both sides, and then multiply both sides by 4, and you get 8 is equal to absolute value of 8b minus 1. And now that we've isolated the absolute value, we can separate. So remember, the inside of the absolute value can be 8, but it can also be negative 8. so now b is 9/8, or b is -7/8. And that is the solution. So if you got those answers, good job. All right, try number 28. And remember, that negative 4 goes with the y. It does not go with the 2. So try number 28. When you come back, we'll do it together. All right, we're back. So you get absolute value of 2 minus 4y is equal to 10. And we've isolated the absolute value, so we can say that expression is equal to positive 10, or it's equal to negative 10. And so now we just solve, and we get y is equal to negative 2, or y is equal to 3. Okay, so if you got those answers, good job. So for number 29, I'm going to put a star next to that because that problem is, it's going to be like this one over here where something weird happens. You're going to get 0. The absolute value, when you isolate it, it's going to be down here. It's going to be 0. So just be aware of that. So go ahead and try number 29, and when you come back, we'll do it together. All right, we're back. Subtract 14 from both sides, you get 0, and then divide both sides by -5, and you get 0 again. So absolute value of x over 6 plus 7 is equal to 0. And so we've isolated the absolute value. We're ready to separate. So x over 6 plus 7 is equal to 0, but x over 7 plus 6, or plus x over 6 plus 7 is equal to -0, but that's the same thing. -0 is the same thing as 0. So it's really just one equation that we need. X over 7 plus, or x over 6 plus 7 is equal to 0. The only thing that would make this true is to make the inside 0. So we get x is equal to -42. So sometimes you only have one solution. So if you got that answer right, good job. All right, try number 30, and when you come back, we'll do it together. All right, we're back. So we get 40 is equal to the absolute value of y over -2 minus 3. And sorry for the sloppy writing. So we've isolated the absolute value, and now we can separate it. So positive 40 is equal to y over -2 minus 3, or negative 40 is equal to y over -2 minus 3. So now add 3 to both sides over here, and we get 43 times -2 is -86. So -86 is equal to y, or add 3 to both sides, and we get -37. -37 times -2 is -74. Positive 74. So if you got that answer, those two answers, good job. So again, you can check if you want. Plug in the 74. 74 divided by -2 is -37. -37 minus 3 is -40. Absolute value of -40 is 40. 40 divided by 5 is 8. 8 plus 8 is 16. Again, the reason I'm doing that quickly is because, I'm just demonstrating that you can test your answer. But you have to use order of operations correctly. Okay, so now these problems have fractions in them. So I'd like to, complete this class without doing any fractions whatsoever. But we can't do that because in math you're going to see fractions a lot. So let's do this problem together. We're going to subtract 8 from both sides. So we get -3, divide both sides by -7, and we get positive 3/7 is equal to the absolute value of 1 minus 4x. So we've isolated the absolute value, so we can separate 1 minus 4x is equal to positive 3/7, or 1 minus 4x is equal to negative 3/7. So now we're going to subtract 1 from both sides over here. Again, this negative, that goes with the 4, or it goes with the 4 and it goes with the x. This whole part is together, but it's not part of the 1. So we're going to subtract 1 from both sides. And in case you forgot how to do that, a lot of students get angry because they say, why aren't you showing me how to subtract 1 from 3/7? Well, you should already know how to do that. That's why beginning algebra and geometry are prerequisites for this course. So this could just be considered 1 over 1. Multiply both sides by 7, and you get 3/7 minus 7 over 7. So this turns to 7 over 7. 3/7 minus 7 over 7 is negative 4/7. So negative 4x is equal to negative 4/7. And again, that negative 4 stays with the x. We just got rid of the 1. We didn't get rid of the negative or the 4. Okay, so let me make that negative a little clearer. So now we're going to divide both sides by negative 4. This is another source of problems for students. Again, this is just basic arithmetic. Now there's two ways you can do this. You can write negative 4 over 7 over negative 4. That's a complex fraction. And then you can multiply both sides by 7. That cancels out the 7 on the top, and you get negative 4 over negative 28, which reduces to 1/7. That's one way to do it. Now again, you might be thinking, I never learned this stuff. Yes, you did. You learned this stuff in beginning algebra or geometry, and if you didn't learn it, or if you don't know it, you got to go back and take that course. Again, there are prerequisites for this course. You can't just take intermediate algebra whenever you feel like it. You've got to get the prerequisites done. Now, another way to do it is to take negative 4 over 7 and use the old school division, like that, and write this over 1, and then you flip this and change this to multiplication, so on and so forth. So there's a number of different ways to do it. Whichever way you prefer is fine. So long story short, we end up with 1/7. Again, all that stuff is just arithmetic. Really, the easiest way to do it is when you divide by negative 4, you're going to see that both the negative and the 4 are going to cancel out, and you get 1/7. When you do this stuff a lot, you're going to get to the point where you're going to be able to do it really quickly. All right, so we're going to subtract 1 from both sides, and now we have negative 3/7 minus 1. Again, the 1 you can just write as 1 over 1. Multiply both sides of this by 7, and you get 7 over 7, and then you just get negative 10 over 7. So that's negative 10 over 7. Then we're going to divide both sides by negative 4, and again, I'm not going to demonstrate all those methods. You should end up with positive 10 over 28, which is 5 over 14. Actually, I'm going to put those boxes together. So again, the only difference with that problem is we had fractions. So again, I'm sorry about those fractions, but you can't escape them. You have to know how to do fractions in mathematics. So for number 32, you're going to see some fractions. So go ahead and attempt number 32, and when you come back, we'll do it together. All right, we're back. Add 8 to both sides, you get negative 4. Divide both sides by 9, and you get 4/9 is equal to the absolute value expression. And now we're going to break it into parts. And we have y over 5 plus 6 is equal to positive 4/9, or y over 5 plus 6 is equal to negative 4/9. It's really important that you make those negatives big enough to where you can see. A lot of students just write a very small negative, and they blend it in with the fraction, and it basically just disappears. I don't want to be a bad influence on you, so I'm not going to allow that to stay like that, because you can barely see the negative. If negatives disappear, then you can pretty much be 100% sure that you're going to get the answer wrong. All right, so at this point, again, it's just basic math. I'm not going to explain the math again. It's just basic arithmetic, and we don't have enough room anyway. So I'm going to subtract 6 from both sides. and we end up with negative 50 over 9. So y over 5 is equal to negative 50 over 9. Multiply both sides by 5, and we get negative 250 over 9, and you can just keep it as a improper fraction. Over here, we're going to subtract 6, and we get negative 58 over 9, so y over 5 is equal to negative 58 over 9. And again, if you are wondering how I'm doing this quickly in my head, if you do the arithmetic enough, you'll get to the point where you can do it quickly also. But you just need to review it. Let me blend that box in. Or multiply both sides by 5, and we get negative 290 over 9. So I know fractions are annoying. They are annoying. But again, you can't avoid them. All right, so the difference with these problems is that we have a 2 here, so we're dividing by 2. We're dividing the absolute value expression by 2, but we're also multiplying it by 3. So I just want you to see these types of problems. So I'm going to show every step of this problem just to make sure that you know exactly what's happening here. So I'm going to rewrite everything. And we're going to add 5 to both sides. So then we get 13 equals 3 times the absolute value of y plus 1, or excuse me, y minus 1 over 2. And then we're going to rewrite that. Again, I'm just showing you the steps here. You don't have to show all these steps yourself, but I just want you to know exactly what's happening here. So now we're going to multiply both sides by 2. And we get 26 is equal to, it cancels out the 2, we have 3 times the absolute value of y minus 1. And then again, just to show exactly what's going on here, we're going to rewrite. And we're going to get rid of that 3 by dividing both sides by 3. Again, when you have a number right next to an absolute value, that means you're multiplying the number, so we have to do the opposite of multiplication to get rid of that 3. So then we end up with 26 over 3 is equal to the absolute value of y minus 1. Y minus 1 can be equal to positive 26 over 3, or y minus 1 can be equal to negative 26 over 3. And if we do the math on that, we see that y is going to be equal to 29 over 3, or y is going to be equal to negative 23 over 3. So those are the answers. Sorry, we kind of ran out of room there. So if you got those answers, good job. So now why don't you go ahead and try 34, and when you come back, we'll do it together. All right, we're back. We're going to isolate the absolute value immediately. So we get 6 over 5. Well, I'm just going to do it by step. So then divide both sides by 5. And we get 6 over 5. And then we just separate. So x plus 2 can be positive 6 over 5, or x plus 2 can be negative 6 over 5. And we just subtract 2 from both sides over here, and we get negative 4/5. And we subtract 2 over here, and we get negative 16 over 5. So if you got those solutions, good job. Okay, let's go on to number 35. We're now going to learn absolute value inequalities. So now instead of an equal sign, we have an inequality symbol. And it says find the algebraic solutions and the graphical solutions of the following inequalities. So let's talk about this a little bit. let's say that we plug in 5. Again, any number that makes this inequality work is a solution. And there's actually going to be an infinite number of solutions. Let's see if 5 works. Absolute value of 5 is 5, so you can see that 5 works. 5 is a solution. Now let's try, say, -4. Let's see if that works. So we're just trying some values here so you can see the possible solutions. So you see that the absolute value of -4 is 4, so that works. 4 is greater than 2. So let's try a value that doesn't work. Let's try -1. Absolute value of -1 is 1, and 1 is not greater than 2. So as you can see, some values work and some don't work. Now, I can try really, really big values, for example, like 98, and that works. And I can try really, really small values, like -98, for example. That's very, very small. Absolute value of -98 is 98, and that works. So really big values and really small values work. So what you're going to find is that if you graph this on a number line, all the values that work are going to be bigger than 2 and smaller than -2. And you can see just by trying values, testing values, you can see that that works. And what we're going to do is we're going to write x. This is the graphical solution, by the way. We have to write the graphical and the algebraic solution. So now the algebraic solution, x is going to be less than -2, and we have to use the word or. X is greater than 2. So again, the algebraic solution and the graphical solution. Let me just put those two together so we can just use one rectangle. And notice I have open circles. The reason I have open circles is this is not greater than or equal to. On this problem over here, we have greater than or equal to. That's going to be closed circles. So this is just one scenario. All right, now we're going to have a second scenario here. And by the way, it's very important that you write or. You're going to see in the next problem, we're going to use the word and I'm going to explain exactly why. Now, you might be a little nervous about this, but what we're going to do is we're actually going to memorize these theorems here. So you might want to take a screenshot of that. These theorems tell you what to do. So if you don't understand all the logic of what we're doing, you can just memorize these, and that'll tell you what to do. But let's talk about the logic a little bit more so you can get a feel for what's going on here. Let's try plugging in. Let's try plugging in 2 for y. See if that works. And absolute value of 2 is 2, so it looks like that works. Now let's try plugging in. Some really small values. So how about -50? That's really small. And absolute value of -50 is 50, and you can see this didn't work. 7 is not greater than 50. Let's try some really big values. So let's try +50. That's really big. And 7 is greater than or equal to 50. You can see that didn't work either. So really big values and really small values, they don't work. But when we tried 2, if I remember correctly, we tried 2, that did work. So what you're going to find, if you keep plugging in numbers, what you'll eventually find is that, and we're going to use closed dots here, because it's greater than or equal to, instead of just greater than. So what you're going to find is all of our solutions are between -7 and 7. And again, that's what the bold means. What this means over here is that all the values can be greater than 2, and all the values over here can be less than 2, but these values inside here, they don't work. For example, if you plugged in 0 to here, 0, absolute value of 0 is 0, 0 is not greater than 2, so these don't work. But over here, all these values do work. For example, if I plug in 0, absolute value of 0 is 0, and 0 is definitely less than 7. So all the values inside, they work, but all these values, they don't work. So that's what this graphical solution means. Now we also want to write the algebraic solution, and again, you just figure this out just by plugging in values. So the algebraic solution is y is greater than -7, greater than or equal to -7, and it's very important that we use the word "and" in this situation. If we don't use the word "and," then it's not gonna be correct. And y is less than or equal to 7. So both of these must be true. Now, if you just say that one of them is true, if just one, let's just say that y is greater than or equal to -7, and that's the only statement that we're making, then you plot -7, and everything bigger than that works. But the problem is, everything bigger than that includes numbers like, 1,000. But over here, you see that doesn't work in the equation. So it's not enough just for this to be true. Both this and this have to be true at the same time, and that means that it's the inner region, not the outer region. So I know that's kind of complicated. And by the way, if you don't understand a lot of what we just talked about, that's okay, because you can just use that screenshot and memorize what to do. So here's what you do. If the absolute value is greater than some number, then we're going to mark the outsides on the number line. But if the absolute value is less than some number, y is less than 7, then it's going to be the insides. And that's what this screenshot tells you. It's just going to be that's this situation here. So again, if the absolute value is greater than some positive number, and by the way, c has to be positive in these inequalities. So if the absolute value of some number is greater than a positive, then it has to be on the outsides. But if the absolute value is less than some positive number, then our graphical solution is going to be on the insides, and we're going to use "and." In this situation, we use "or." These are very, very important things. And you can also write it like this, but we're not going to talk about that much in this class because I don't want to confuse you with too much information there. So let's see here. So those are the two primary situations that we're going to be dealing with. We are going to be dealing with other scenarios like these down here. So we have one theorem, 2 theorems, 3, 4, 5, 6 theorems total. And these are the basic situations in purple and green, but we're going to have, again, these special situations that we're going to talk about in these problems down here. But right now, we're just going to do those basic. So again, get a screenshot. If you haven't gotten a screenshot, you really need to get a screenshot of this so you can see what's going on. So either you can think about the logic of these inequalities, or you can just memorize that screenshot. So why don't you try number 37? And it's going to be either this or this. You have to figure out which one it is. So the absolute value is less than a number. That's like saying in the screenshot, the absolute value of x is less than or equal to c. And I don't know if the equal sign is really that important in this, but try 37. And when you come back, again, you want to do the graphical solution and the algebraic solution, and it's got to be either this or this situation. Now, be aware that sometimes you can flip the inequality. So, for example, you might have absolute value of b is greater than or equal to 2. You can actually flip it. And as long as you flip that inequality also, this is the same thing as this, you see. So it's very easy to get confused. And if I write the absolute value of b is less than or equal to 2, and then I flip that, and flip the inequality also, then these two are the same expressions. But these expressions are not the same as these. So it can be very confusing. So you really have to be careful and get used to that notation. So why don't you try number 37, and when you come back, we'll do it together. All right, we're back. So the absolute value is less than or equal to 4. It's less than or equal to a number. That's this situation here. again, it's kind of confusing because this is flipped. But again, remember the Pac-Man eats the bigger numbers, so that means that the absolute value is less than 7. So that's the same thing here. Pac-Man wants to eat the bigger number. That means this is less than. So look at your screenshot. When the absolute value is less than, you have this situation, and we have to use and. So again, you can memorize all that green stuff there. So that means that b is greater than or equal to -4, and you have to use the word and. B is less than or equal to 4. And the graphical solution, we want closed circles because it's less than or equal to. And you have -4 and +4, and you're going to color in that region there. So if you got that answer, good job. Now I know that this is very new stuff. I understand that. But you have no excuse. You may be confused. You may think, I don't understand what's going on. All you have to do is follow these rules. If you don't understand what's going on, just follow these directions, and eventually you're going to memorize this. Okay, and that's what most students do. You know, they don't want to think about all the logic of it. They just want to memorize, what do I do? That's perfectly fine. But you just need to get these problems done. Don't tell me that you can't do them because you don't understand what's going on, because again, most students, when it comes to like 75% of the curriculum, most students don't know what's going on. And, you know, this may sound crazy, but you don't really need to know what's going on at first. At first, you just need to learn the notation. That's the primary purpose of this course and every algebra course, is to just learn how to read and write the math. Once you get that down, then you can go back and get the whole of the logic. So now try number 8. And when you come back, or excuse me, number 38, and when you come back, we'll do it together. All right, we're back. So if the absolute value is greater than some number, that's this situation. Again, you can look at your screenshot there. So x is less than -8, and you have to use the word or. X is greater than +8. So that's the algebraic solution, and we want open circles because it's not less than or equal to, it's just less than. So we're going to color in this part and this part. And what that means is that all the values can be here or they can be here, but the values cannot be inside here. It doesn't work in this inequality. So if you got that answer, good job. I forgot to put the numbers there. But you have to put or. You have to write or. Now in this situation, I didn't explain, in this situation you need and. I did explain that, but why is it or in this situation? Well, because this cannot be true and this at the same time. So if x is less than -8, that means it's a number over here, but that cannot be true at the same time that this is true. A number cannot be less than -8 and greater than 8 at the same time, so you have to say or. Whereas this can be, both these things can be true. A number can be greater than -4 and less than 4 at the same time. So that's why that makes sense. Now again, if you're a little fuzzy on that, that's okay. But if you got the right answer, good job. Now if you struggle with that, again, just go back to your screenshot. That's your salvation. That's your savior, is that screenshot. It'll tell you what to do. Okay, so now we're going to go to some special situations. Let's try some values here. Let's plug in 2. And that works. Plug in 0. And that works. And if you just keep plugging in numbers, you're going to find that any number works. It doesn't matter what number you plug in here, all of them work. So the answer is y can be any real number. That's the answer. So that was kind of a specialty problem. Whenever the absolute value of a number is greater than a negative number, y can be anything. It can be any number. So I'm writing that in red just to let you know that that was kind of a special problem. Now that situation is right here in blue. X can be any real number. The only difference is I wrote a greater than rather than greater than or equal to. But it's still any real number. Okay, so for number 40, number 40 again is a special situation. Let's try plugging in some values here. Let's say plug in 1. Absolute value of 1 is 1. So is -3 greater than 1? It is not greater than 1, so that didn't work. Let's try plugging in -2. Absolute value of -2 is 2. Is -3 greater than 2? No, it's not. Again, you can use your Pac-Man. Pac-Man wants to eat the bigger one, but this is clearly not the bigger one, so it didn't work. If you get confused by this, you can always use Pac-Man. So let's try plugging in 0. Absolute value of 0 is 0. Is -3 greater than 0? It's not. So what you'll find is there's no number that we can plug in here that makes it work. It's impossible for the absolute value of a number to be less than a negative number, because this is always positive. It's always positive or 0. The smallest we can make this is 0, but even that is not less than -3. So the answer is no solution. So these are just some special cases that you may see. And that situation, when the absolute value is less than a negative, that's this situation in blue, where there are no solutions. So again, this screenshot is your salvation. Again, you can get a screenshot of that if you need to, if you didn't get one already. Okay, let's go to some more weird situations here. So absolute value of b is greater than 0. And what you're going to find is that all values work in this. Just plug in, -1,000, you get absolute value of a -1,000. That would be 1,000, and it works. Plug in +1,000, it works. Plug in any number, it always works, except 0. Absolute value of 0 is 0, and 0 is not greater than 0. So in that situation, that's the purple on the very bottom here. X can be any number except 0. So b can be any real number except 0. And let's put that in red, because again, that's a special situation. Now, I didn't talk about real numbers. You're probably thinking, why am I saying real numbers? Well, you're going to find in this course that there's something called complex numbers and imaginary numbers. And so we want to specify that we're just talking about real numbers. Real numbers are just any number that you're used to using, that you've already used, in the curriculum so far. It's just any number that is not on the imaginary plane. We're going to talk about that some other time in this course. So now we have one more special situation when an absolute value is less than or equal to 0. So you're going to find that there are no values that work in this inequality except 0. So y can only be 0. Y is equal to 0. That's the answer. And why is that true? Well, you can just plug in values and find out for yourself. We don't really have time to go over it. But when an absolute value is less than or equal to 0, that's this situation. Theorem number 4, then x is only equal to 0. Or excuse me, y, in this case, y is only equal to 0. So those are the 4 situations. So we've done we've done all 6 theorems. We did this theorem, this theorem, this theorem, this theorem, this theorem, this theorem. So now I want you to try. We already did all of these, so we're not going to do these anymore. But the next 4 problems, you're going to use one of these theorems down here. Again, we don't have time to do any more of these today. Well, we're going to do some of them, but we're going to get to more complicated ones. So try number 43, and I'll leave the absolute value inequality theorems in the window. Try number 43. It's going to be one of these theorems, and when you come back, we'll do it together. All right, we're back. So absolute value is less than 0. Looks like that's going to be this top situation here. Remember, C can be 0. So in that case, C would be 0. And we have no solutions. So if you got no solutions, good job. I know that's kind of complicated to look at this notation, because you might think, well, wait a second, isn't it this one? Well, it's not that one because we're not dealing with a less than sign, a less than or equal to sign. And you're probably thinking, well, how could it be this one? That's not 0. Well, again, C is a non-negative constant, but that doesn't mean that it can't be 0. So C would be 0 in that situation. So try number 44, and when you come back, we'll do it together. All right, we're back. So that is the situation, theorem number 5. And again, C is 0. So x can be any real number. It doesn't matter what you plug in there. Y can be any real number. It doesn't matter what number you plug in there, it's always going to work. So if you got that answer, good job. Try number 45, and when you come back, we'll do it together. All right, we're back. So absolute value is less than or equal to 0. That would be theorem number 4. Then we can see that b is only equal to 0. That's the only value that would work. And again, these are special situations, so I'm coloring them in red. Now again, if you want to know why this is true, you want to know the logic behind it, just plug in a bunch of values and see which ones work. 0 is the only one that works in that equation, or that inequality. These are not equations, they're inequalities, remember that. So 46 is the last one of these strange problems, so try number 46, and when you come back, we'll do it together. All right, we're back. So absolute value is less than a negative number. Looks like that's going to be theorem 3, and you can see there are no solutions. It doesn't matter what you plug in there. There are no solutions. None of them are going to work. No real value is going to work in that inequality. Okay, so if you got that right, good job. So that's the basic information about inequalities. Now we're going to go to some more difficult inequalities. And you can see we have an inequality with all kinds of complicated stuff there, but we're going to do it just the way we did it with equations. We're just going to isolate that absolute value. So I'm going to subtract 2 from both sides and multiply by 7, and I get 21 is greater than or equal to negative 2b minus 3. Absolute value of that. So now the absolute value is less than a positive number. If it's less than a positive number, then that's this situation in green. So that screenshot will tell you what to do. So negative 2b minus 3 can be greater than or equal to positive 21, and you need the word and. Negative 2b minus 3 is less than or equal to, wait a second, that's not right. That should be less than or equal to 21, and this should be greater than or equal to negative 21. So let me just make sure that's right. Everything looks right. So now what we do is we just carry down this and we just solve these inequalities, and that'll give us the algebraic solution. So add 3 to both sides, and we get negative 2b is less than or equal to 24. Now this is very, very important right here. Pay attention to this. We now have to divide both sides by negative 2. But if you divide both sides by negative 2, you have to flip this inequality. Remember that? So we have negative 12. Whenever you divide or multiply both sides of an inequality by a negative, you have to flip. You don't always have to flip, but when you're multiplying or dividing by a negative, you do have to flip the inequality. So we're going to bring down that word and. We're going to do the same thing over here. Add 3 to both sides, and we get negative 2b is greater than or equal to negative 18. And divide both sides by negative 2, and we have to flip the inequality, again, because we divided by negative 2. And we get b is less than or equal to 9. So now if we graph this, again, it must be closed circles because we have equal to signs. It's going to be 9 and negative 12, and it's going to be the inner part here. So that's the algebraic solution and the graphical solution. So again, when you get to this situation, you just look at your screenshot, and it works just the same way as we did all the easier problems. The only difference is you have to solve these inequalities to get to this point. And remember, whenever you multiply or divide by a negative, you have to flip that inequality. All right, so now we're going to isolate the absolute value again. And now the absolute value is greater than. So what that means is it's the theorem number 1. It's the purple situation. So that means that negative 2 plus 6y is greater than 2, or we have to use the word or. Negative 2 plus 6y is less than negative 2. So I'm going to move this over a little bit. Okay, so then we just bring the word or down and we solve, add 2 to both sides, divide by 6, and we get 2/3 if you reduce. And add 2 to both sides and divide by 6, and we get y is less than or equal to 0. Now we did not have to flip the inequalities because we didn't have to divide by a negative. We just divided by a positive 6. So we're not flipping the inequalities. And so now let's do the graphical solution. We have 2/3, and this is going to be an open circle, and 0. And y is greater than 2/3, or it can be less than 0. And so that is the graphical solution. Again, we're doing the same exact thing that we were doing before. The only difference is we have more complicated inequalities that we have to solve. Okay, so now it's time for you to try. Go ahead and try number 49. And when you come back, we'll do it together. Remember, when you multiply by negative 5, you're going to have to flip those inequality signs. So try 49, and when you come back, we'll do it together. All right, we're back. So we're going to subtract 3 from both sides, divide both sides by 2, and we get the absolute value of x over negative 5 plus 6 is less than or equal to 2. All right, so now we have the absolute value is less than or equal to 2, so that's the situation where we have x over negative 5 plus 6 is greater than or equal to negative 2, and we have to use the and word. X over negative 5 plus 6 is less than or equal to 2. So now we just bring the and down and we solve. So subtract 6 from both sides, multiply both sides by -5, and now because you're multiplying both sides by a negative, that inequality is going to flip. All right, and over here, same thing. Subtract 6, we get -4, multiply both sides by -5, and we get 20. But again, we have to flip that inequality because we multiply by a negative. Up here, we didn't divide by a negative, so we didn't have to flip those. But in this first problem, we did have to flip. All right, so just double checking that. And so now we're going to do the graphical solution. And we have 20 and 40. X is greater than 20 and less than 40, so that's going to be this inner part here. And that is the graphical and algebraic solution for that inequality. So if you got those answers, good job. If you did something wrong, that's okay. We're going to do more of these problems so you can get some more practice. So try number 50. And you're not going to have to flip the inequalities on this one because you're not going to have to divide or multiply by a negative. So try 50, and when you come back, we'll do it together. All right, we're back. Add 3 to both sides, multiply by 4. We get 20 is less than absolute value of 8 plus 3y. Now, if an absolute value is greater than a number, use your screenshot there, and we know that 8 plus 3y has to be greater than 20, and you have to use the word or. 8 plus 3y is less than -20. That's just the situation. That's just what you have to memorize there. So we have y is less than 4. And over here, if we solve, we have y is less than -28 over 3. Again, we did not have to flip the inequalities because we're not dividing by a negative. If this were 8 minus 3y, then we'd have to flip the inequality because we'd have to divide by a -3. Here we just divided by a +3, so the inequality stays the same. Now we're going to do the graphical solution. Y is greater than 4. Over here we have -28 over 3. So that would be over here, and less than -20 over 3 would be over here, and that is the solution. So if you got that answer, good job. Okay, on to number 51. Now something different is going to happen here because we're going to have to flip this inequality before we even separate into two inequalities. So we're going to subtract 2 from both sides, and we get -7 is less than absolute value of 4 plus 6y over -5. And so I'm doing this step by step. So watch what happens. When I multiply both sides by -5, we get 35 over here, and I'm going to have to flip that inequality again before we even break into two inequalities. I'm already having to flip that inequality because I multiply both sides by a -5. So at this point, now we have the situation where the absolute value is less than 35. So that means that 4 plus 6y has to be greater than -35. And again, if you don't remember what to do with this, just look at that screenshot. 4 plus 6y has to be less than +35. So we solve and we get y is greater than -39 over 6, and y is less than 31 over 6. So now if we do the graphical solution of that, we have open circles, and -39 over 6 and 31 over 6. And so it's going to be the inner region here, but it's not going to include those the numbers on the open circles. So that's why we have to write open circles. So if you got that answer, actually we did that together. So again, the difference with that problem is we had to switch the inequality pretty soon in the problem. So now let's try another one of those. So we're going to subtract 8 from both sides, and we get -1. And I'm just doing this step by step so you can see exactly what's going on. You don't have to show all these steps. So now we're going to divide both sides by -4. But notice that we're dividing both sides by a negative. That's -4. So what that means is we have to flip that inequality. So again, that's the difference with this problem, is that we're having to flip the inequality pretty soon in the problem. So now this absolute value is greater than 1/4. So that means that it's going to be the outside situations. So b over -6 minus 2 is greater than positive 1/4, or b over -6 minus 2 is less than -1/4. So we're going to bring down the word or, add 2 to both sides, and now, again, we have the situation where we're having to add fractions, but that's just going to be 9/4. Again, 2 plus 1/4 is 9/4. And now we're going to have to multiply both sides by a negative. If you do that, you have to flip that inequality. So now it's going to be less than sign. B is less than -54 over 4, which reduces to -27 over 2. Again, if you have problems with that, you can just go back to my beginning algebra course or my arithmetic course. So that's one solution. And over here we're going to add 2. And that's going to be 7/4. Multiply both sides by -6, and you have to flip the inequality. And we get -42 over 4, which reduces to -21 over 2. So now we're going to write the graphical solution, and we need open circles. I'm just going to pull these problems down a little bit. So now, let's see here, -27 over 2 is a smaller number, so that goes there, and this is the bigger number. And it has to be less than or greater than, and that's the graphical and algebraic solution to that inequality. So again, that's another example where you have to flip the inequality pretty quickly in the problem. And you have to flip the inequalities down here too. So now, why don't you go ahead and try number 53, and when you come back, we'll do it together. All right, we're back. So subtract 4 from both sides, and you get -48. Divide both sides by -8, and you get +6. And you have to flip that inequality. Oops, sorry, it's a little sloppy there. And so now we have the situation where 6 plus 3b is greater than 6, or 6 plus 3b is less than -6. So subtract, just solve, and we get b is less than 0, or greater than 0, or let's see here, we have -4. And we did not have to flip the inequality because we're not dividing by -3, we're dividing by +3. So now we're going to do the graphical solution. Open circles, -4, 0. And we're going to color in the outsides. Again, if you're not sure about what you're supposed to do, the color the inside or the outside, you just go to that screenshot. It tells you when the absolute value is greater than a positive number, it's the outsides. All right, so if you got that problem right, good job. Okay, on to number 54. Go ahead and try number 54. And when you come back, we'll do it together. All right, we're back. So we get, looks like we get 28, and you have to flip the inequality. And then we're going to have to divide both sides by 3. And we get 28 over 3. And so it's greater than, so we have the same situation. 2 minus 5x is going to be greater than 28 over 3, or 2 minus 5x is going to be less than negative 28 over 3. Again, look at that screenshot and it tells you exactly what to do. So now we just have to solve those inequalities. Subtract 2 from both sides, and we get, looks like 22 over 3. Now divide both sides by negative 5. And again, this is just basic arithmetic. We don't have time to go over all the steps for that, but x, we're going to have to flip the inequality because we're dividing by a negative. And we would end up with negative 22 over 10, or excuse me, over 15. And that's pretty much all we can do for that one. Over here, we're going to subtract 2. And we get negative 34 over 3. Divide both sides by a negative 5. We have to flip the inequality, and we get positive 34 over 15. So now we're going to write the graphical solution. We have open circles again, and x is greater than 34 over 15 and less than negative 22 over 15. So I know we had some fractions there, but you know, you're just going to have to deal with fractions sometimes. I wish I could, you know, avoid those altogether, but we just can't. Now we're going to have some special situations in these problems. So let's do these first 4 together, and then you can do the last 4, and then we'll be done for the day. So in the previous problems, we had the purple up here that was occurring, and we also had the green. But in the problems that we're going to do now, we're doing these situations. So we have to identify, first what we're going to do is isolate the absolute value. So we're going to add 10 to both sides and then multiply both sides by negative 8. And because we're multiplying by a negative, we have to flip that inequality, and we get negative 8 over here, and we have absolute value of b over 3 plus 4. Might as well move this down. I don't need that much room. So again, we just isolate the absolute value. And so now, in this situation, you should stop there. The absolute value of something is greater than or equal to a negative number. The absolute value is greater than or equal to a negative number. So that means that whatever's inside the absolute value can be any real number. It tells us right there. So what that means is that b over 3 plus 4 can be any real number. Which means that b can be any real number. Again, think about it. If this can be any number, it doesn't matter what it is. then we can just plug in any b value we want, and it's going to make this, some number. But again, every number works in this equation, because absolute value of a number is always going to be positive. The smallest that you can make this is 0, but 0 is still greater than -8, so any value works. So that was a special situation, so I'm going to color that in red. So those are the type of things that we're going to have for these next problems here. Let's see what happens on 56. Subtract 6 from both sides, and we get 2 is less than or equal to -8b minus 3. And notice that this negative does not go with the 6. It goes in front of the absolute value. So now this is the same thing as -1 times the absolute value, of 8b minus 3. So we're going to divide both sides by -1. And be careful, because that flips the inequality. So then we have -2 is greater than or equal to the absolute value of 8b minus 3. And so what you'll find, and we have absolute value is less than a negative number. Absolute value is less than a negative number. So as you can see here, that means there are no solutions. It doesn't matter what you plug in there for b, it's not going to work. It doesn't matter what value you end up with in the absolute value. It's not going to be less than -2, because this is always positive. The smallest that you could make this number is 0, but that still is not going to be less than or equal to -2. So the answer is no solution. So one way that you could say it is there is no number that 8b minus 3 can be that will work in the inequality which means there is no value of b that will work either. So that's just one way to describe it. You really don't, you can probably just put no solution. You don't have to write all this, but I'm just writing that for your benefit. So let's try a couple more of these before you try one on your own. We're going to add 2 to both sides, and we get 0 is less than or equal to -7 times the absolute value of y over -5 plus 1. And now we're going to divide both sides by -7. 0 divided by -7 is just 0, but we have to flip the inequality because we divided by a negative. So now the absolute value is less than 0, so there's no value that you can plug in for y. I mean, the absolute value is less than 0. Well, maybe we should just go over here. Absolute value is less than 0, less than or equal to 0, that is. So that's actually theorem number 4. So that means that the inside part can only be equal to 0. So again, what you're going to find is there's nothing you can plug in here that will make the equation work except 0. For example, if all this ends up being, say, 11, absolute value of 11 is 11, 11 is not less than or equal to 0. Let's say all this ends up being -11. Absolute value of -11 is 11, 11 is not less than 0. It doesn't matter what you plug in, it's not going to work. The only thing that will work is if this equals 0, because it is true that 0 can be greater than or equal to 0. Because again, it's greater than or equal to. So what does that mean? It means all we have to do is say y over -5 plus 1 is equal to 0. And that's the only equation that's going to give us our answer. Subtract 1 from both sides, multiply both sides by -5, and we get 5 is equal to y. So 5 is the only solution. I'm going to color that in red, again, because these are special problems. So now let's try one more of these before you try some on your own. We're going to add 1 to both sides, and we get absolute value of b plus 3 over -2 is less than 0. Multiply both sides by -2, and we get the absolute value of b plus 3 is greater than 0. And if an absolute value is greater than 0, that is the bottom situation here. X can be any real number except 0. Now, again, you might think, well, why is that? Well, you just plug in values and you can see inside here it can be anything. You can plug, if this were 5, then absolute value of 5 would be 5. That's greater than 0. If it were -5, absolute value of -5 is 5. It's still greater than 0. Anything we plug in there is going to be greater than 0. Everything's going to work except 0. Because if it ends up being 0 inside, if b plus 3 ends up being 0, absolute value of 0 is not greater than 0. They're equal to each other. They're not greater than each other. So that means that b plus 3 So there's a couple different ways that you could write this. One way that you could write it is b plus 3 cannot be equal to 0. And then subtract 3 from both sides. You can see that b cannot be equal to -3. And that assumes that b can be every other value. So we write a -3 here. And b can be all the values below -3 and all the values above -3, but it cannot be -3. That's one way to do it. Another way to do it is to say that b plus 3 can be less than 0, or b plus 3 can be greater than 0. And just solve for that. So b is less than -3, or b is greater than -3. But you can see that this is kind of complicated. It's a lot easier just to do this. Whenever you see that b is not equal to -3, that assumes that it can be any other value. And there may be some controversy about what exactly is the best method, but most people will just stick with this because it's obviously much simpler. So in that situation, that is the answer. And we don't want b plus 3 to be 0. So if we plug in -3, that makes it 0. So that's why b cannot be -3. But it can be any other value. So I'm going to color that red because, again, that was a strange situation. So now you have 4 problems left for today, and they're all going to be weird situations like this. Again, these are all theorems 3 through 6. So go ahead and try number 59, and when you come back, we'll do it together. All right, we're back. Subtract 4 from both sides, multiply both sides by 3, and we get the absolute value is less than 0. We didn't have to flip the inequality because we're multiplying by a positive 3. So now there's no value that makes this work. There's no solutions. An absolute value is less than 0. That would actually be theorem number 3. And C would be 0 in that case. Again, I know these can be kind of confusing because sometimes C can be 0 and sometimes it's assumed to be 0. But we can just write no solutions. I'm not going to write a big explanation. Again, that's all you have to write. No solutions. And so if you got that one right, good job. Why don't you try number 60, and when you come back, we'll do it together. All right, we're back. Subtract 7 from both sides. Divide both sides by -2. And we're going to have to flip that inequality. So now, is there anything that we can plug in there that would make it less than 0? Well, there's only one value that it can possibly be. When an absolute value is less than or equal to 0, then the inside part, inside the absolute value, can only be 0. So 3 minus 7y can only be 0. So we're going to subtract 3 from both sides, divide both sides by 7, and y is equal to 3 over 7. So if you got that answer right, good job. All right, try number 61, and when you come back, we'll do it together. All right, we're back. Subtract 4 from both sides, divide both sides by -2, and we get -6, and we have to flip that inequality. And now, it doesn't matter what we plug in for x, it's always going to make it bigger than -6. So absolute value is greater than a positive number. That would be this situation. X, the part inside the absolute value can always be, or can be any real number. So we can just say x can be any real number. Now I gave a more in-depth explanation in the previous problem like this, but we don't really have time to give an in-depth explanation. All you have to say is x can be any real number, because this inside part can be any real number, and it'll still make the inequality work. So if the inside part can be any real number, then that means x can be any real number. It doesn't matter what we plug in; it's always going to satisfy the inequality. All right, so why don't you try number 62, and when you come back, we'll do it together. All right, we're back. Subtract 8 from both sides, multiply both sides by 4, and you get 0 is less than absolute value of y over 2 plus 5. And absolute value is greater than 0. Let's go over here. That means that x can be any real number except 0. So that means that y over 2 plus 5 cannot be 0. Now let's see what y would have to be in order to make that true. It looks like y could not be -10, because if you plug it in there, you get 0. Or excuse me, you get 0. So y cannot be equal to -10, and if you graph that out, it looks like that. So that means that we can plug in any number less than -10 and any number greater than -10, and they all work. So again, we've got the algebraic solution. Here we've got the algebraic solution, or actually down here we've got the algebraic solution. And we should only rectangle the this part here. Those are the solutions. So we've got the algebraic solution, and we've got the graphical solution. So if you got those answers, good job. Now if you struggled with those, that's okay. These are challenge problems. But remember, your salvation, your savior, is this here. This is going to give you an idea of what to do in these different scenarios. So that was the class today. So let's go ahead and get screenshots of the work that we did today. But before doing that, I want to mention something. I forgot to graph some of these solutions. Now, if you have no solution, there really is no graph. But if you have y equals 3/7, then really all it is just a dot, with on a number line. So it's not really that important. But I did technically say to graph these. So for example, if you have y equals 5, again, that's just a dot on a number line. If its b is not equal to -3, then you have an open dot, and the region around it is colored. So Those were problems 55 on, and then also these problems here. I forgot to graph these. B can be any real number except 0, so that's colored outside an open dot on 0. And if y equals 0, it's just a dot on 0. So just be aware of that. Also, some of these problems, the answers were a little bit different depending on the detail of the description. So for example, for number 59, the answer was no solution. For number 56, the answer was also no solution. But instead of writing no solution for 56, I gave a big explanation, you see. Just because that was just for your benefit. But again, be aware, you don't have to write all this. You can just say no solution. So if you get kind of confused when you compare number 56 and 59, you know, it's the same answer. You can just say no solutions. So that said, let's go ahead and take screenshots. So here's screenshot number 1. And screenshot number 2. And screenshot number 3. And screenshot number 4. And screenshot number 5. And screenshot number 6. And screenshot number 7. Now don't go before you get your homework. Let's take a look at the homework. So here's the homework. Get a screenshot of these first 2 pages. And a screenshot of the last 2 pages. So remember, you need to do your homework completely, correctly, neatly, and keep it in order in your binder. And if you don't do the homework, it's 100% guarantee that you're going to learn absolutely nothing in this entire course. So get that homework done, and remember, put your name, the date, the course title, which is Intermediate Algebra, and write a title for your homework, and rectangle all your answers, show all your work, circle the problem numbers, so on and so forth. This is just all basic stuff that you need to do for all your math homework. So get that homework done, and I'll look forward to seeing you in the next class.